If you're sitting the Victorian selective entry exam, then quantitative reasoning is one of the sections that's changed a lot in the last few years. And so if you want to maximize your chance of getting into Melbourne High, Macrob, Nossal, or Suzanne Cory, this is definitely a section where you want to understand what's changed so you can capitalize on it, but also what stayed the same so you can make sure you're strong in those areas as well. And so if we firstly get started with what is quantitative reasoning, one big change is the number of questions. So last year they dropped it down to 45 questions in 30 minutes, which means it's one of the least time pressured sections on the exam. The counter to that is there is questions that take longer. So there's a real mixture of questions in this section. There's patterns questions, which are pretty fast to answer. And it really comes down to you either instantly can see the pattern, you can get it right in a pretty short period of time, or you can end up wasting a lot of time on them. On the other hand, there's also a lot of worded problems, which really test year 8, year 9 math skills that you would have learned at school, but in real life worded scenarios, which do make it quite a bit more challenging to actually figure out what's being asked of you. And so in terms of what success looks like on this section, it's really very similar to other sections where you're ranked against every single other student sitting this section with the top score at the top, the bottom score at the bottom, and you want to be in about the top 10%. So if you can be in about the top 10% for 3 of the 5 sections on the exam, that's going to set you up pretty well for success. And the good thing is, even though quantitative reasoning is a maths-based section, and so you would think, well, do you need to be really good at maths at school? The truth is that you can improve at this section really quite quickly, even if maths isn't one of your strongest sections. For example, this section used to be called numerical reasoning. When I sat it, it was quite similar. There was a few differences, but it was fairly similar to what we see now. The first time I sat the selective entry exam was when I was hoping to get entry into Melbourne High for year 9. Unfortunately, that time, I got a really low score in this section, and it was actually my lowest performing section. I was never really strong at maths at school, and so initially this section was one that I found a little bit more difficult. But the next year, I applied again for year 10 entry. That time, I luckily did get into a selective school. I got into Melbourne High, and this was actually my best section. And so it went from being my worst section to my best section just through understanding the strategies and the techniques for how you can master all the different question types in this section. So even if you sit a mock exam, the first attempt is more difficult and you find it really quite hard, that's okay. It's a section you can improve very, very quickly if you go through it, you understand all the different types of questions that are in the section, and you learn strategies and techniques for becoming more confident in it. And that really is one high-level piece of advice across every single section of the exam. You really want to avoid falling into the trap of thinking, I'm bad at quantitative reasoning, I'm bad at maths, I'm bad at writing, I'm bad at reading. A lot of people fall into that category where they also tell me, look, I'm pretty good at these 3 sections, but I'm really bad at maths. I'm just not a maths person. I can't do well in maths. And the reality is that for every single section of the exam, there's about 10 or so question types. Some there's slightly more, some there's slightly less. If you focus on one question type and you ask yourself, what strategy do I need to learn? If I learn that strategy, then I'll be able to answer that question correctly every single time. There's always a strategy you can learn. And I almost guarantee it, if you focused on one question type for 2, 3, 4 days, just obsessively until you've mastered it, and you do that for every single question type in the section, it doesn't matter what the section is, you can definitely become really skilled at it. Because the reality is a selective entry exam, it's not that difficult. There's always going to be a strategy, a technique, a tool that's there. If you learn it, you'll be able to get the question right. That's really the key thing. And so there's 2 main types of questions in this section. The first one being number patterns and patterns in general. And the second one is worded problems. In this video, we're going to mainly focus on number patterns questions and the specific strategies that you can use to get these questions right. Because the interesting thing is the number patterns questions, they're kind of almost similar to what you would see on an IQ test. And so it's natural to think, well, these are probably ones where you can't really improve that easily. And I've seen a lot of people say there's no strategy for these. You just have to be good at them or you can't. But the key thing is I know from my own experience, you can improve at them. I wasn't necessarily amazing at them at the start, but I learned a few strategies which made them pretty achievable. And now I'd say they're pretty fun, they're pretty relaxing to do because I know the strategies for how to pick them apart. So number patterns questions, what does that actually mean? Here's a few examples here. Really what they're testing is your ability to quickly find a pattern. For example, in example number 1, we can see 6, 36, 72, 3, 9, 18, 5, 25, and something. Now this pattern is not too difficult, I would say. It's probably one that's fairly reasonable. What we can see is that 6 multiplied by 6 gives us 36. So 6 is being multiplied by itself, which gives us 36. 3 multiplied by itself gives us 9. 5 multiplied by itself gives us 25. So the first part of this pattern, which I'll just quickly draw it here for us, is essentially these first numbers here. What's the pattern here? The first number is multiplied by itself. 6 by 6 equals 36, 3 by 3 equals 9, 5 by 5 equals 25. After that, it's just simple, they're multiplied by 2. 36 times 2 is 72, 9 times 2 equals 18, 25 times 2 is 50. Now, so the right answer here was 50. Same thing with this one here, it just went 3, 6, probably 12, 24. Both of these patterns were not too hard, but you might be wondering, well, how did you actually find those patterns? Because maybe you found these patterns easily, maybe you didn't, but how do you find it systematically every single time? It can't just be a game of luck, otherwise you're not going to consistently get high scores. There has to be a method or a system to finding the patterns if you want to get really good at these questions. And the good thing, there is a system that you can follow to make solving these questions a lot easier. The key thing to accept, firstly, is that there's always a pattern there. There's always a pattern that exists. We just need to find it. And so there's kind of two key steps to finding the pattern. The first one is recognizing the pattern. So looking at this example here and recognizing what you think is the pattern. And so in this case, we thought the pattern is probably the first number is multiplied by itself, and then it's multiplied by 2. The second step is then utilizing the pattern. So we think we've got the pattern. There's always going to be a few situations where we can test it to see if you've got the right answer. So that's the really good thing about number patterns, in that you'll always know if you've got the right answer or not. Because if you find a pattern, you can test it a few times in a few different situations, and you'll be able to figure out, is it correct or not? So in this case, we thought, based on this first row, the first number gets multiplied by itself to give us a second number. The second number then gets multiplied by 2. We can test that. 3 by 3 equals 9, so that's holding true. This number multiplied by itself gives us 9. And then same thing again, 9 times 2 gives us 18. Same thing with this one here. We thought the initial pattern was either probably plus 3 or times 2. Now, if it was plus 3, that wouldn't work. There's just no way these series of numbers would work with plus 3. Whereas if it's multiplied by 2, 3 times 2 equals 6. 6 times 2 equals 12. 12 times 2 equals 24. So it's kind of two key stages with these pattern questions. Step 1, look for the pattern. Try to recognize what the pattern is. Second step, utilize the pattern. Test it in a few different situations. You'll know if you've got the pattern or not. And the key thing with these questions is, if you can't spot the pattern very quickly, you do want to move on. You do want to leave it until the end, because you don't want to spend a couple of minutes wasting your time on these. These are questions where it's very easy to waste time searching for the pattern, getting all stressed, not finding it. If you can't find it within a short period of time, move on to another question, leave it until the end. You can come back and look at it later. Now, let's have a look at the few different types of patterns that can exist, because luckily, there's 4 main types. And understanding the types does make it significantly easier to find the pattern. First type is increasing patterns. This is where the numbers are only going up. Second type is decreasing patterns, which is where the numbers are only going down. Third one is fluctuating patterns, where the numbers are going up and down. And then there's trick patterns, which includes decoys or jumps. So we're going to work our way through each of these in today's video. Once you understand these 4 types of patterns for most questions, you're going to be pretty covered. It's almost always going to fit into one of these categories. And so if you're really fast at spotting them, it's going to make it a lot easier to understand and quickly see what the pattern actually is. So first one, increasing patterns. What are they? Now, as the name suggests, these are just patterns where the numbers are increasing rather than decreasing. Each number is higher than the next. For example, 4, 8, 12, 16, 20. It's going up by 4 each time. 100, 110, 210, 220, 320. This one's a bit harder. It's going plus 10, plus 100, plus 10, plus 100. Increasing patterns are generally fairly easy to understand. And you might be wondering, well, why does it even matter calling it an increasing pattern? What does that actually do to help us make it easier to solve? It's important because if the numbers are always increasing, it tells us 2 key things. It means that either, if the numbers are increasing by a small amount, it's probably addition. That's the pattern. For example, if the numbers are going from 2 to 4 to 6 to 8 to 10, could it be multiplication? Not really. Like, it wouldn't really be possible. We know the pattern has to involve addition. It's probably plus 2. Whereas if it's something like this, 749, 343, 2401, it's increasing by such a large amount each time, it's probably multiplication. And so this is really the key thing. If you see numbers increasing by a small amount, there's probably addition involved. If it's increasing by a larger amount, it's probably multiplication. And if it's increasing by a weird amount that doesn't really seem that normal, then it may be a mixture of both. It might be like the number's getting multiplied by 3 and then we're adding 1. Or it's being multiplied by 4 and then we're adding 1, for example. So let's take a look at a few examples. This first one here, 6, 24, something, 384. Now, based on what we just saw, we know that if the numbers are increasing by a massive amount, multiplication is most likely involved here. Because sure, the pattern could be plus 18, plus 18, plus 18, but that's not going to work. And so it's probably going to be, what, 6 times 4? It's 24. 24 times 4 is 96. And then 96 times 4 is 384. So right away, we know the pattern there is times 4. The reason why we can jump to that so quickly is we know numbers are increasing by a large amount. And so what's the likely pattern? It has to probably be multiplication. And so B96 was correct here. Same thing with this one here. This one's a little bit different. I would look at these two numbers straight away, 105 to 122. And I'd ask yourself, is it possible for multiplication to take us from 105 to 122? How possible is that? And the answer is not that possible at all. And so it probably has to be addition there. What's 122 minus 105? It's 17. And so my guess is the pattern is probably plus 17 every time. 71 plus 17 equals 88. 88 plus 17 equals 105. 105 plus 17 equals 122. And so again, just by looking at the relationship between these two numbers, they're going up. So it has to be multiplication or addition or a mixture of both. And is it possible for multiplication to be involved? Not really. It would be a really, really weird combination of patterns, that's for sure. So it had to be kind of be addition there, which made it easy. Now we'll do one more. What is the missing number in this sequence? 16, 33, something, 135. Now this one's a little bit more difficult because we can see the numbers are increasing by a lot pretty quickly, but then it doesn't quite look like it's just multiplication. Like if it went from 16 to 32, then we'd know, okay, it's probably times by 2. It could be plus 16, but it's probably times by 2. But it goes from 16 to 33. And so what that tells me is there's probably 2 steps there. My guess is, having seen a lot of these patterns, it's probably going to be times 2 plus 1. 16 times 2 gives us 32, plus 1 gives us 33. Let's test it. We've recognized a pattern. Let's utilize it. 33 times 2 equals 66, times 2 equals 67. So my guess is that 67 is correct here, but we can test it again. 67 times 2 equals 134. 134 plus 1 equals 135. So that gives us a pattern there again. So this was a bit harder. The pattern was times 2 plus 1. 16 times 2 plus 1 equals 33. 33 to 67. 67 to 135. So this is probably the next step up in difficulty. When there's a mixture of both addition and multiplication, does make the pattern a little bit harder to solve. Now, we'll quickly have a look at these ones here, because these ones are a little step up again in difficulty, because there's more information there. They're in these grids or in these triangles. So for this one here, right away, we can notice that if we look from this side here to this side here, numbers are increasing. 4 to 12, 5 to 15, 12 to, it looks like times 3 is a pattern, doesn't it? It really does look like 4 times 12, 4 times 3 equals 12, 5 times 3 equals 15. So this one here is probably 36 realistically. And so right away, we know it's probably one of these two. So I'd cross these two out. And probably that one. Now we then know it goes 12 to 13, 15 to 16. So it's obviously just going to be plus 1 is that next step of the pattern. And so this number's 37, obviously. But then what's the pattern here? It looks like times 2, times 2. So this one here is going to be multiplied by 2 as well. So it's going to be 36 and then 26, which is this one here. And so we can see when it's increasing, this was fairly easy, I'd say. The pattern was times 3 plus 1 times 2. So not too bad. With these ones here, these ones require a little bit of a different strategy. What we want to do here is you want to look inside the triangle, but then you also want to look outside. Because often the numbers outside the triangle, some sort of calculation between them is going to lead to the one inside. In this case, I'd say 12 plus 3 equals 18. 22 plus 14 plus 6 gives us 42. And so it looks like the numbers on the outside are just being added together. 9 plus 8 plus 4 equals 21. And so 21 would be correct here. So that one was kind of easy because you just added the things that were outside the triangle together. Sometimes you might multiply them together. Sometimes you might multiply these two and then minus this one. There's a few different ways that it could be, but normally it's some sort of arrangement of the outside ones leads to the inside one, most of the time. So that's increasing patterns. So key thing with increasing patterns, what do you need to remember? Increasing patterns are when the numbers increase every single time. If it's increasing by a small amount, probably addition. If it's increasing by a larger amount, probably multiplication. If it's increasing by an amount that looks a bit weird, it's probably a mixture of both. So decreasing patterns now, I think you understand how this is probably going to work. So we'll only do a few practice questions on this one, but it's when the numbers are decreasing. For example, 20, 15, 10, 5, 500, 100, 24. Again, these are pretty common. And if I said, well, when numbers are increasing, we look to multiplication and addition. If numbers are decreasing, what would we look at? What would we look at in that situation? And the answer is, of course, subtraction or division. They're the two prime suspects for the pattern in this case. So if the numbers are decreasing by a small amount, probably subtraction. 96, 88, something, 72. Now, is it possible to use division to go from 96 to 88? Possibly. It would be very difficult. Not really at all. And so this pattern's probably just going to be minus 8. 96 minus 8 equals 88. 88 minus 8 equals 80. 80 minus 8 equals 72. Whereas if the numbers are decreasing by a larger amount, then we know probably division. 640 to 160 to something to 10. Division has to be involved there, realistically. And so same thing again, if the numbers are then decreasing by a weird amount, then it's probably a mixture of both subtraction and division. So let's look at two quick ones here. 480 to 240 to something to 60. Now, the numbers are decreasing by a pretty large amount, divided by 2. My guess is divided by 2 again, divided by 2. That would work. So it looks like the pattern here was a fairly simple one. Each number was dividing by 2. 480 to 240 to 120 to 60. And so 120 is what we want for this one here. What about this one here? It's increasing by what I would say is kind of a weird amount. It would be, what's that? That's 21. Minus 21. If we try that here again, we'd get minus 21 would get us 121, which would get us 100. And so the pattern in this case was minus 21. 163 minus 21 gives us 142. 142 minus 21 gives us 121. And then 121 minus 21, of course, gives us 100. And so decreasing patterns, it's the opposite of increasing patterns. Numbers decreasing. We want to look at subtraction and division as the prime suspects to create the pattern. Now, fluctuating patterns, some of you might be able to guess what this means, but a fluctuating pattern is where the numbers are both increasing and decreasing. The key thing with these, we'll have a look at a quick example. For example, this one here, 440, 20, 200. So there's a bit of movement there. It goes from 4 to 40, back to 20, shoots up to 200. 100 to 50 to 150 to something. The key thing with these patterns, these are slightly more difficult, but if you know how to use and spot increasing patterns and decreasing patterns, this is just using both skills together. We want to isolate the movements. So what you want to do is you want to have a look and see, okay, this here it's increasing, and over here it's also increasing. And so you want to just look at the increasing pattern first. 4 to 40, 20 to 200, that's increasing by times 10. We then want to flip it and just look at the reverse. So in this case, it went from 40 to 20, which is probably divided by 2. From 200 to probably 100 divided by 2. And so you want to just break it into a part, look at the increasing patterns, and then look at the decreasing patterns as well. And that gives you a lot of clarity about what the pattern actually is. So that's kind of exactly what it says here. Treat each movement separately. When the numbers are increasing, look at addition and multiplication. When they're decreasing, look at subtraction and division. So let's do two quick practice ones for this one. 220 up to 440. That's probably times by 2. 440 down to something. Then back to 220. Then back to 55. Now this one is a little bit more difficult at first glance because when you see 440, you think it should go straight back to 220. But let's just have a look at each movement in isolation. So 220 up to 440, that's probably multiplied by 2. Then 440 to something, not sure. What would 440 be going to? Not sure. Goes to 220. And then we can see here 220 back to 55. And so what I'd say is this looks like it's times 2. This looks like it's divided by 4. So that's the first stage. I think I've recognized the pattern. I think when the numbers increase, they get multiplied by 2. I think when they decrease, they get divided by 4. And so now the second stage is utilize the pattern. Let's see if it's correct. So this is multiplied by 2, so that's fine. Then I would think that if this pattern here, which is divided by 4, holds true, it should go 440 down to 110. And then if this pattern holds true again of dividing it by 2, it should go back to 220 and then back to 55. So we can see that was the pattern. And so the pattern in this case was multiplied by 2, divided by 4. Multiplied by 2, divided by 4, which gives us that correct answer of being a 110. Now, one final fluctuating pattern. This one here, 100 to 20, 60 to something, to 36. And so in this case, what it looks like is probably, again, divided by 5. 100 divided by 5 gives us 20. 20 times 3 gives us 60. 60 divided by 5 gives us 12. And 12 divided by 3 gives us 36. So we can see that's correct as well. Correct one here was 12. So the pattern was essentially divided by 5 times 3. Divided by 5 times 3. And so key thing with fluctuating patterns, treat each movement separately. Like we did there, you look at where it decreases, you think, okay, what's a pattern there? You look at where it increases and you say, okay, what's a pattern there? You look at, find those two patterns together, and that's your overall pattern. Now, final things are trick patterns. There's two major tricks that we see a lot on the exams. The first one is a decoy number, a decoy pattern. And this just essentially means where they just add a number in there or a series of numbers that are the same, that are designed just to distract you. They kind of distract us. So for example, this pattern here, 17, 8, 17, 16, 17 something, 17, 32. Looks slightly more confusing when you see this here because there's all these random 17s. But in this case, the 17 is a decoy. And if we actually just ignore the 17, it just goes from 8 to 16, from 16 to something, and from something to 32. And so it looks like the pattern's probably just plus 8. 8, 16, probably 24, 32. The 17s just confuse us. We can just ignore them. They're decoys. And we can just look at the pattern at hand, which is simple, plus 8. So really the key thing with decoys is decoys, they normally happen in one or two situations. Either it's the same number repeating like this, or it could be a number that is at the end or the beginning of a large number. So for example, if we had like 160, and then we had 1 at the end. 180, 1. 200, 1. In this case, this pattern would still actually work, but sometimes they might just put some random number at the end of a long number, which then makes it seem weird, but you could just cut out that last number. Or very often, it might just be something at the start. It might be like this, 0, 2, 4, 6, 8, what? And so 0 is just a decoy. Or it might be 6, 36, something. And so the 0 here is just a decoy. So sometimes there is like a 0 or 1 at the start, which is a bit of a decoy. If you see that, it's probably a decoy. The key thing is it's generally repeating at a regular and consistent interval, or it's just at the start. So let's have a look at a few practices just to make it a bit clearer. This one here, 0, 3, 10, 31, something. As soon as I see a 0 at the start, I think it's probably a decoy number. I'm just going to ignore it for now and see what the pattern could be. 3 to 10 could be plus 7, but that wouldn't really work here. So it's probably times 3 plus 1. 3 times 3 equals 9, plus 1 equals 10. 10 times 3 equals 30, plus 1 equals 31. 31 times 3 equals 63, plus 1 equals 93, plus 1 equals 94. So that would be our pattern here. It was times 3 plus 1. Same thing for this one here, 0, 99. So straight away that really tells us that 0 is probably going to be a decoy number there. 99 to 114, it's probably plus 15. 114 to 129, probably plus 15. 129 to 144, probably would make sense. Another 0 there at the end as a decoy. And so 144 was correct. The pattern was just plus 15 each time. Now one final one that is a little bit more difficult. How do you think you would approach this one here? So this one does look a little bit more difficult, I have to say. It does look a little bit more difficult, so I'm just going to scan it now quickly. Now what I'd say is the 2 zeros in the corner are probably going to be decoy numbers. For these types of ones, you generally want to look down and up, but also on an angle. Now when I look down and up, I can't really see an obvious pattern. There's plus 5 here, plus 3 there. Don't really know there. That's plus 2, not sure. So it's not super clear. So if we look on an angle, this would be 5 to 6 would be plus 1. 7, 9 to 11 would be plus 2. If this was plus 3, 11, 14, 17, that would work. Plus 4. So what the pattern actually looks like, which is a bit of an interesting pattern, is plus 1 here, plus 2 here, plus 2 here. This next row then was plus 3, 11 to 14, 14 to 17. Yeah, that works. And then this final one here was plus 4. And so this number should be 14, which is the answer. Good. So in this case, this was a bit of a trickier one. You had to look on the diagonal. You had to ignore the zeros. Otherwise, you would have been in a bit of a mess. When you see these like grid or box ones, just look straight up and down and then look on diagonal as well. Don't forget diagonal, because that can sometimes be where the answer is. Now, the final trick is one that does look very confusing when you don't know how to look for it. But once you see it, it makes complicated looking patterns simple. And it's called pattern jumps. And this is where there's two patterns within the one sequence and they're going back and forth between each other. So for example, this one here goes 2, 3, 4, 12, 6, 48, 8, and 192. Now, when you particularly look at these first four numbers, you'd say, my goodness, what on earth is a pattern there? But if we actually just highlight this here, 2, 4, 6, 8. So what we see is there's a pattern here which is plus 2, plus 2, plus 2, plus 2, which is a super easy pattern. It's as easy as it gets. It's just jumping a number, which is why it's called a pattern and jump. The other one is then just times 4. 3 times 4 equals 12. 12 times 4 equals 48. 48 times 4 equals 192. So these pattern jumps, they do come up quite a bit, and they're a big trick, and a lot of people will get them wrong. And so if you can spot them out quickly, it's a big way to give yourself a bit of an edge on these pattern types of questions. The key thing is these patterns will always apply in a consistent interval. It'll never like jump 1 and then jump 6. If that's the pattern that you're seeing, then it's probably not the pattern. So we're going to have a look at a couple of these now. Key thing with spotting these is really just to try and isolate. Just think, okay, 1, 2, 3, 4. Okay, yeah, that looks like a pattern. 190, 967, 64, 61. Okay, yeah. So normally, once you know what to look for, if you look for a jump, they do normally jump out at you, I would say. So let's have a look at a few examples. This one's kind of easy. 1, 2, 3, 4. 64, 128, 256, something. So we can see there's really two key patterns here. The first one is just going 1, 2, 3, 4, 5, 6, 7, 8. And the other one is multiplying the numbers by 2. 64, 128, 256, 512. So C for 512 is correct here. And then final one, 4. Let's map this one out because it's slightly more harder. 4 to 16, so probably times by 4. 16 to 64 times by 4. And so 64 times 4 would give us 256. So that's probably going to be the right answer. Let's check though. 2, 4, 8. So this one looks to be times by 2. So the next number would be 256. And then this one, what would it be? It would go 2, 4, 8. So they've been multiplied by 2. So it would be, of course, 16. So these pattern tricks, look out for them. Two main ones are decoy numbers where there's like a 0 at the start and the end, or the same number that's repeated, which just kind of is there to distract you, so you can just ignore it. It's just not a part of the pattern. You can ignore it completely. Or pattern jumps is where there's two patterns together that jump over each other. So that's another thing to look out for. Otherwise, the key thing with patterns is if you practice a lot of these questions, you can get very good at them very quickly. And so in terms of exam strategy, how do you tackle this section of the exam? Specifically for pattern questions, the key thing is during your preparation, you want to focus on doing as many of these questions as you can and creating what I'd call a pattern journal, where every time you see a pattern, you note it down. Because the reality is there's only so many patterns that can exist in the world in these types of questions. And so if you note down every single time you see a pattern, you're going to notice the same ones coming up again and again and again. And that's going to allow you to get faster and faster at spotting them because you would have seen all of them before after you've done 500, 1,000 of these questions. So that's the first thing. Create a pattern journal during your preparation, which will make it easier for you to spot them. In the actual exam, essentially you want to be smart about it in that if you can't see a pattern quickly within the time that you have allocated to that question, leave it and come back to it at the end if you have time, because it's very easy to get stuck looking at one of these and just not knowing what the pattern is and wasting way more time than what you have. And so you want to be smart about it. Every question on the exam is worth the same amount of marks. If you don't see the pattern within the time limit, just move on. That's okay. In this section, you probably need about 80 to 90% to get a superior or to be in the top 10% of students, which is what we're aiming for, like we said at the start of the class. And so you can afford to leave a few of them until the end and just guess them if you have to, if you can't see the pattern right away. And so that brings us to the end of today's quantitative reasoning training, where we really deep dived into the number pattern questions in particular. Hopefully you feel a bit more confident with these questions. I'd recommend doing a bunch of them straight away after this video to practice some of these skills for yourself. And the key thing is quantitative reasoning is a section where if you really focus on each question type in a lot of depth, there's no reason why you can't learn the strategies and techniques you need to be able to answer them very, very quickly and easily. And so just before we wrap up today's session, There is some free practice questions below this video. I'd recommend downloading them if you haven't yet. Otherwise, if you want our help with tutoring, you want to get tutored by me in the lead up to the exam, there's a link below this video where you can book in for a call with us and get some more information about that as well. And so good luck in your quantitative reasoning practice, and I'll see you back here in another video very soon.